आवाज आ रही है ये फोनोग्राफ से, ढूंढो खुदा को दिल से ना लाफो गज़ाफ से।
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to another intriguing episode of Future of Work. I am your host, Abdul Qadir Ismail Uluwagbemiga. If you have been following our journey this season, you would know that we have been exploring the forces reshaping the world of work. And today, we are zooming in on one of the most mind-blowing revolutionary frontiers of them all, quantum computing. This episode is titled, The Quantum Evolution, Engineering the Future of Computing. And it couldn't be more fitting because what we are talking about today isn't just about faster computers. It's a complete reimagination of how we process information. Imagine solving complex problems in seconds that would take classical computers thousands of minutes to solve. That's the promise of quantum computing. And it's not just hype. It's a new era of possibilities, from cryptography to drug discovery, climate modeling, to AI. But it also comes with challenges and ethical questions we've never had to face before. To help us unpack all of this, we have two guests who are deeply immersed in the world of advanced computing and innovation. First, we would have Vakor Abdulmujib Ali, who is a seasoned software engineer with over 7 years of experience. He holds a degree in computer science from the University of Illinois. He has worked with top companies like Meta, Binance, and Asos. He also worked on projects such as Messenger, Instagram, and cryptocurrency exchange apps. He is also passionate about leveraging tech to solve real-world problems. Abdul Mujib, Assalamu alaikum wa rahmatullahi wa barakatuhu.
Wa alaikum salam wa rahmatullahi wa barakatuhu.
It's a pleasure to have you with us, sir.
Jazakumullah khair. It's nice to be here too.
We also have joining him, also virtually, Bello Abdul Fattah, who is also a seasoned IT leader who boasts of 19 years of experience in delivering large-scale solutions and driving business transformation across Africa. He is a certified Scrum Master. He excels at leading cross-functional teams and managing multi-million-dollar projects, focusing on innovation, client satisfaction, and technology-driven business growth. Abdul Fattah Sahib, Assalamu alaikum wa rahmatullahi wa barakatuhu.
Wa alaikum salam wa rahmatullahi wa barakatuh.
We're happy to have you with us, sir.
Thanks for having me.
Beloved viewers, what does the future of computing look like? And how do we prepare ourselves, our industries, and our systems for this radical transformation? We'll have the discussion now. But before we move on, we have interviewed some individuals to get their views about what they have to say about quantum computing. Let us listen to them.
So quantum computing, if you have to break it down into two words, we have quantum and we have computing. So when we take the quantum aspect of it, that is, we are talking about quantum physics. So when we say quantum physics, I'm sure everyone has heard of Albert Einstein, Niels Bohr and the likes. So now quantum computers, traditional computers uses bits, which is your ones and zeros, which we're all aware of. But they will tell you that 1 is on, 0 is off. But now quantum computers are now different. there is something called qubits. So when we say qubits, that is, it can be 1 or 0 at the same time, which is very significant in developments.
Quantum computing is a strong aspect of quantum physics. And this quantum computing rather, make use of qubits instead of like other computers make use of normal bits. The normal computer make use of zeros and one, but this quantum computing make use of zeros, one, and even both of them. That means it can make super things, like when something can use zeros and one at the same time, not differently, at the same time. So it is a very strong aspect of quantum of computer.
Yeah, so all writing quantum computing will impact technology in the future. So I'm just to take this latest research discovery by Microsoft. So I'm just search it. It is called Marama. So it's just a small quantum computer. It can fit the palm of my hand. So I want us to look at how far we've gone in computers. Before, you've heard of ENIAC, EDAC, and the rest. It could take up houses just to set up a simple computer. But now, with that small chip in my hand, we can perform calculations instantaneously. An example of how quantum computers work is this. Let's take a maze, for example. We know a maze now, there's a single point of entry, then there's an exit, but you have many shortcuts to defraud the maze. Normal computers will do what? It will follow a straight line to find the exits. But quantum computers will solve each part at the exact same time, which cuts out the computational time. So making it easier for researchers to do their calculations easier and faster.
This quantum computing is going to make a great impact in future, It's going to speed up the discovery of like new medicines, like speed up and make people determine the best drug and one that will be very accurate to the human body.
Welcome back. Viewers, you would agree with me that quantum computing is indeed very interesting. So let's get started. Mujib Sahib, can you please tell us what exactly is quantum computing and how does it differ from the classical computing we all know about?
Assalamu alaikum warahmatullahi wabarakatuh.
Wa alaikum assalam.
All right, so I'll try and break it down in a way that is easy to follow. At its core, quantum computing is a completely new way of processing information. It is based on the principles of quantum mechanics, which is the science that explains how the tiniest particles in the universe, like atoms and electrons, behave. Now, in the classical computing system, which is what we have currently powering our laptops and our phones, everything boils down to bits. So a bit can be in one of two states. It's either a 0 or a 1. So like a light switch, that's either something that is off or something that is on. This binary system is really good for most tasks, but it has its limits when it comes to solving really complicated problems. And that's where quantum computing comes in. On the other hand, quantum computing uses things called qubits instead of bits. And it gets really exciting from this point. So instead of a qubit can be either a bit can be either 0 or 1, right? A qubit can be 0 and 1 at the same time. Stay with me. So thanks to a property called superposition. So imagine having a coin that is spinning in the air, and instead of just having heads or tails, where is either one side of the coin is facing up or the other side of the coin is facing up. In a qubit, both sides are facing up until you catch it. What this means is it allows quantum computers to process a massive number of possibilities all at once. So there are a number of classical physics experiments that describe this in more detail, but let's go with this very basic application explanation that I just gave. Another key difference with quantum computers is entanglement. So it's like a mysterious connection between qubits, and when qubits are entangled, changing the state of one qubit instantly affects the state of the other qubit, even if they are far apart. So this allows quantum computers to solve certain problems in a way that is much faster than what we have with the classical computers, even the ones performing operations in parallel. So to put it simply, classical computers are like reading one book at a time, while quantum computers are like reading an entire library simultaneously.
Wow.
And this makes quantum computing incredibly powerful for tasks like simulating molecules for drug discovery, optimizing supply chains, cracking complex encryption codes, which is something that has a lot of the cybersecurity community on edge right now. That said, quantum computers are not here to replace classical computers.
Okay.
They are more like specialized tools that they are built for solving specific types of problems that classical computers struggle with. So it's unlikely that your phone is going to be using quantum computing anytime soon. But in industries like healthcare, finance, and energy, this technology is already transforming how they work. So it's a really exciting time to be alive.
What this means is that quantum computing is like the big brother to the classical computers, when they can perform the tasks that seem difficult for the classical computers will be performed with their quantum computers in very little time.
Yeah, I wouldn't necessarily call it big brother, but
okay.
it's a good evolution of what we have in classical computing.
Well, is it also possible for the quantum computers to perform the task of the classical computers? What will happen?
Technically, yes, but I think quantum computers are built to solve certain types of problems. So I'd say that it's like it's going to be overkill trying to apply quantum computers in the same way we apply classical computers today. So it's a specialized technology.
Okay, so quantum computers are built for special purposes, while the classical computers continue to perform their own normal task. Okay,
yes, or in conjunction.
Jazakumullah khairan for the insight into what quantum computing really means. You've given us the breakdown. In fact, you used layman language which would be more understandable to our viewers at home. We'll come back to hear more about quantum computers from you. But now, going to Fatah Sahib, can you tell us some of the most exciting real-world applications of quantum computer, and probably some of the things we expect to see in coming years?
Like my brother here has said, he has mentioned some of the real-world applications of quantum computing that we expect in coming years. Some of them could be the drug discovery and medical research, you understand? Solving complex optimization problems. Because the quantum computer is a game of speed. It's quite faster than the conventional computer. And for this reason, it specially can simulate molecules of chemical reactions with high precision that can lead to discovery of new drug faster and understand disease at the molecule level. Another area is the cybersecurity. Okay, we are all aware that the world of today is full of hackers, full of cyberbullies, cybercrime. So quantum computing can also help in this area by creating quantum-safe cryptography and making systems more secure to be able to run. You understand? Some other areas, quantum computing more likely to impact our lives is the climate modeling and the environmental science. You understand? Weather forecast, understanding what the weather will be like in couple of days, couple of months, and also renewable energy material development. Another area is artificial intelligence, because it enables smarter AI systems. We're in a world whereby AI is now taking a real shape, and things are looking more different. So quantum computing will also help in enabling smarter AI systems and improve the pattern of recognizing and predicting accurately. In financial services is another area. I read an article that extensively discussed about how quantum mechanics would actually help in fraud detection. So in this area, a lot of banks will be buying into this solution to help them secure banking transactions online. And many more.
So
breakthrough will happen.
basically, some of the industries where quantum computing will be most useful, we're talking about industries like healthcare, we're talking about finance, we're talking about security, probably the security industry, people who study something like criminology might want to know more about quantum computing. So that do you think it's something that is helpful in that field?
In fact, it's helpful in most of the fields that are relevant today. What I've just mentioned is just a few amongst them. We have a lot of places because it's a computer system that deals with speed and solve complex problems. So if researchers can look into quantum mechanics for any solution, it will definitely fit in.
Oh, that's great. So Mujib Sahib, so from what you have said, coupled with what Afatah Sahib has just said, it means quantum computing is a very wide field, and I'm sure that engineers or quantum engineers would face multiple challenges compared to people who deal with the classical computers. Can you tell us some of the challenges that quantum engineers face, and what progress has been made in overcoming these challenges? How can we overcome these challenges that you face?
Okay. So, as someone that follows the advancements in the field, a few challenges that come to mind, although like I must preface this by saying that there's been a lot of progress in recent years.
Wow.
But I'll start with a few challenges. So the first one, qubits, which I explained earlier as the building blocks of quantum computers, are very fragile. So they lose their quantum states, which I explained earlier, in a problem called decoherence. So due to even small changes in their environment, like temperature fluctuations or electromagnetic waves, these qubits can lose their quantum states. So imagine trying to balance a pencil and you put a pencil by its tip or even by its bottom on a table, and then you turn on a fan and you are blowing it towards the pencil. The truth is it won't stay upright for very long. So that's kind of the analogy I can put together here. Early qubits only maintained coherence for microseconds, but with today's systems like Google's neutral atom qubits, Microsoft has also made some good progress here. So they've pushed these milliseconds into seconds in some cases. Another one is errors. So unlike classical bits, qubits cannot simply be copied for error checking, and qubit operations are, by their very nature, very noisy. So for example, 2 qubit gates, for a basic operation, like something that is quite easy to do with bits, with classical bits, often have error rates as high as 1%. So to tackle this, engineers are developing advanced error correction methods. Companies like Microsoft have demonstrated logical qubits, which bundle multiple physical qubits to detect and correct errors. Recently, I think there was up to a 22% or 22 times improvement in error rates.
Wow.
And even AWS, Amazon Web Services, has a chip called the Ocelot chip that reduced error correction costs by 90%. So these innovations are making quantum systems a lot more reliable. Scale is another challenge. So adding more qubits creates more noise and more complexity. So there are new systems from IBM that show progress here, but connecting thousands of qubits while maintaining coherence between them or with the qubits remains very tough. So engineers are experimenting with hybrid systems that combine quantum and classical computing while allowing practical applications, even with today's imperfect hardware, which is why I was trying to say earlier that it's definitely not a replacement. It's most likely going to work in conjunction with the systems that we have today. Finally, there is the challenge that the hardware in itself is very complex. Quantum computers require very cold temperatures and precision engineering to isolate these qubits. So companies like IBM, Google, and others are exploring diamond-based systems that might eventually operate at room temperature. The truth is that the field is moving much faster than many expected, and breakthroughs in error correction, hybrid architecture, and qubit stability are turning theoretical promises into tangible tools. The truth, and we all have to just live with the fact that a fully fault-tolerant quantum computer might still be, at least at scale, might still be far away in the future. But there is a lot of significant progress in the field that suggests that we are getting closer and closer every day. The journey is not over, but with the amount of creative engineering that goes into the field these days, I'm sure that these challenges will be tackled and resolved.
Yeah, the interesting thing is that all of the challenges are being tackled head on. Even when it seemed like, oh, it's going to take a couple of years to solve a particular problem, in very few years you discover that the problems are being resolved with immediate effect. I feel like even you as the engineer will feel like, how did we get to this level? Because yes, we are in the future and people are working. We have challenges and we must solve these challenges. And if there is a machine that can solve the challenges for us, we have to work on them to get the best out of this machine and to get the best of what we want. That's interesting. It's interesting to know that we are moving at a very fast pace. Now, Abdulfatah Sahib, while you were talking the other time, you told us some sectors where quantum computers have been integrated, where it has been used. It is currently in use. So now, what we want to know now is, how do quantum engineers, how do they collaborate? How do they work with people from other sectors? How do they work with other sectors? How do they get what they want? Because looking at the fact, we have mentioned these challenges, we have mentioned what it takes to work in their own industry, in their own sector. So how do they work with people from other sectors?
Thank you very much. Let me take this with a real life scenario. Okay, when I was working with IBM, okay, whenever I want to deploy software, so what we do is that we use the application path integration technology, API, like a plugin. You understand? So now let's come back to quantum engineers, how they actually integrate towards resolving complex problems like this. Okay, I'll pick pharmaceutical company first. In pharmaceutical company, what they do is that they study the biologists, the chemists, and develop a quantum algorithm, like a set of rules, a set of data structure, a set of program that will simulate the molecule structure, thereby predicting, and how medications can interact with human body. So in the financial sector, what they do is that they are trying to also use the quantum mechanics to understand and analyze. So they perform analysis on the financial part and then optimize based on the kind of patterns or the results that they get. So, and in the energy sector, what they do is that, what I mean by simulation is that they try to do, like in our lane language, copy. They try to see like on a staging environment where I would just, okay, if I have this pattern like this, what will be the result? They do multiple tests with the quantum mechanics and arrive at a good market prediction. The same for energy, energy area, environmental science, and a lot of cross-functional areas. So they do the quantum algorithm using the cutting-edge quantum technology. They analyze and simulate, and thereby coming up with a solution that would help real-world applications.
It means it actually takes a lot. There is a lot of collaboration. There is a lot of process that goes into this working together, or do I call it collaboration with other sectors. It means we have to do a lot. If you are working as a quantum engineer, you must be willing to collaborate. You must be ready to collaborate with people extensively to give them what they want and to be able to even get what you need. That's interesting. Mujib Sahib, from the discussion, we discovered that quantum engineering requires a lot. But there are quite a number of people out there who feels like, yes, this quantum engineering. A lot of people feel like it is very difficult to be a quantum engineer. And some people are of the opinion that, yes, it is easy. It's something I can do. What advice would you give to someone who feels like, I love this field, I would love to take this path, but feels like, I think from what I'm listening to, this is going to be a very difficult hurdle to cross? What would be your advice?
So if you are a young person, not even a young person, I don't want to be accused of ageism, but if as a person anywhere in the world and you're curious about quantum computing, I'd say that there are so many opportunities in the field. More opportunities are coming up every day, and it's a great time to be getting in. You also don't need to be like a physics or math genius or even have access to the expensive laboratories to get started in the field. So I'll try and give some practical steps towards building a career in quantum computing, especially where you can apply, wherever you are in the world. The first one is start with what you have. So there are too many free online resources about quantum computing today, and learning materials are available entirely free. So there is a platform like IBM's QuizKit. It's a free Python SDK that with a YouTube channel that offers free tutorials and even access to real quantum computers through the cloud. And you can check out free courses on platforms like edX, Coursera, and YouTube, like I said earlier. So there's a playlist called Quantum Computing Fundamentals on MIT's YouTube channel, which is also like a very great starting point. So I say don't underestimate the power of learning things by yourself. There are a lot of people from modest backgrounds that have mastered complex topics by just being consistent with online resources. A second thing is definitely even a non-negotiable is that you need to build a very strong foundation in math and programming. So quantum computing relies heavily on mathematics, especially linear algebra, probability, and complex numbers. The good thing is that these are skills that you learn in what we call further math in Nigeria or in undergraduate math. So we already have like the exposure to the building blocks of these technologies, and we can only just build more expertise within them. So also programming skills like Python come in really important. So Quizzkit is based mostly in Python. You need access. You also need to learn some of the modeling or the tooling in Python to get started on this. You also have, but there's also access to, like, you can try using formal education.
So,
like I said earlier, and then there are things like Khan Academy, Brilliant. There are just so many resources that you can try.
What you're saying, in
to.
essence is, so there is a lot of learning process involved, and you must be willing to take up the challenge of learning. So when you are able to learn, then it will be easier for you to fit in to the field. So that's taken. So Fatah Sahib, what would be your own advice to people who, or individuals who intend to go into the field of quantum engineering?
Okay, just to buttress what my brother have said, I would just encourage such individual to be very patient, be willing to learn, okay, because one must be science enthusiast, you understand. It might sound difficult, all the technical terms and becoming rooted in this area. So the first I would just recommend is going to a mentorship program. Okay, get someone who is already in this field and try to understudy that person. Have a roadmap. In the next 1 year, I would like to enhance my programming knowledge. Maybe begin to learn Python. Try to check what IBM has on Quizzkit, like my brother said. Look at how you can also learn using the social media, YouTube. Coursera is very good. You have a lot of initial courses for beginners, and you can begin to think about certifications in this line. Tailor your understanding to those certifications, and gradually you can also look into internship in this field. And before you know it, as day goes by, one would be getting there.
Once again, just be resilient, learn, take up the challenge of learning. It might seem difficult, but without pain, there is no gain. What you have to do is just keep pushing. It is not easy, but nothing in the world comes easy. Even Allah the Almighty has said in the Quran that the success of man has been tied with difficulty. So when you go through difficulties, doesn't mean you will not get to where you want to get to. Just keep pushing and you will get to what you want. Jazakumullah khairan, Abdul Fatah Sahib. Jazakumullah khairan, Mujib Sahib. Our viewers, thank you very much. Jazakumullah khairan for being with us throughout this episode. I'm sure that you have learned one or two things. And if you are willing to go through the path or to toe the path of quantum engineering, do not go back. Do not fear. It's something you can do. And it's going to be easier than you could ever think of. May Allah continue to be with us all. If you have any comments, questions, or observations, do not hesitate to reach out to us via africa@mta.tv. I remain your host, Abdul Qadir Ismail Uluwagbemiga. And until we meet again on another episode of Future of Work, I say, Assalamu alaikum wa rahmatullahi wa barakatuhu.
जब तक अमल नहीं है दिले पाको साफ से, जब तक अमल नहीं है दिले पाको साफ से, कमतर नहीं ये मशगला बुत के तवाफ से कमतर नहीं, ये मशगला बुत के तवाफ से।